Hello everyone, welcome to our channel. In this video, I'll show you how you can easily create this adaptive grid in SwiftUI without using GeometryReader. Let's get started. First, let me create a grid item just for the demonstration. You'll use your own model instead of this grid item. Mine basically consists of an ID and a color. Then, I'll create an extension to the color to get a random color for every grid item I create. This is also for demonstration. You can let users select the color they want for the items you have in your app. Here, I create a color based on random RGB values. Let's create an array consisting of our color items. This is the extension we've just written. Now, here is the important part. I'll create an adaptive columns, which is an array of grid items with adaptive width of minimum and maximum values. When we use these adaptive columns in vertical grid, it will decide the best value for the width considering the view container it is in and the spacing value, and try to fit as many columns as possible. Let's continue and see how it can be used. I'll start with a navigation stack and then use a scroll view for our items. Inside it, I'll use a LazyVGrid, and the columns will be the adaptive columns we prepared earlier. For every item we have in items, I'll place a rounded rectangle with a corner radius. Then I'll color them with the grid item color, which is randomly created. Remember that adaptive columns decides only the best width for the rectangles here. For items to be perfectly squared, we can use aspect ratio modifier. I'll also write the item number on each grid using the overlay modifier. Now, as you already know, SwiftUI decides the best width within the minimum and maximum limits we have given. Therefore, a maximum of 3 columns can be fitted within the given parameters, and SwiftUI does it. When we add padding, SwiftUI calculates the best width value for the columns and goes with 2 columns instead of 3. Let's also add a navigation title here. Let me show you where the spacings we used affect the layout. This determines the spacing between rows. And here, if you change the spacing, it affects the spacing between columns. Here is where the magic happens. When you change the device orientation, SwiftUI handles the number of columns and widths of the items by itself. You don't have to use GeometryReader, which can lead to expensive calculations if not used correctly. And also, you don't have to manually change the columns' values based on the orientation. In the end, there are lots of devices to support in the iOS and iPadOS families. You can play with the minimum and maximum values of the columns based on your needs. That's it. Thank you for watching. Please don't forget to subscribe to our channel and like the video to support us.